composite and metal 3D printing, along with deep knowledge of reverse engineering, product lifecycle management, and digital inspection. He has successfully led projects that help organizations reduce product development cycle, optimize costs, and achieve higher levels of precision and quality in manufacturing. His ability to bridge the gap between technology and business strategy has earned him recognition as a turned trusted advisor and thought leader in the additive manufacturing domain. Beyond his corporate and institutional engagements, Mr. Srinivas Garu is also a strong advocate for knowledge sharing and capacity building. He has contributed to training programs, industry workshops, and academic collaborations, mentoring professionals and students to develop competencies in cutting-edge manufacturing technologies. His commitment lies not only in advancing business objectives, but also in nurturing talent and strengthening the future workforce of the industry. With proven track record of delivering value, enabling innovation, and fostering collaboration, Mr. Praveen Jadi Garu continues to play a vital role in transforming the landscape of additive manufacturing and advanced engineering solutions in India and beyond. So with this introduction, I welcome sir. Now I request you to start the session, sir. Thank you. So please switch on your mic. It's
Yes, sir. Thank you, sir. Thank you, Santara sir, for giving very big introduction about me. Yes, sir. Thank you, sir.
It is an honor, sir. Okay. Thank you for accepting our invitation, sir. First of all,
thank you, sir. And yes, sir. Actually, Lakshman Rayudu sir known for last 6 to 7 years in additive manufacturing. So I will tell my brief introduction, sir, how my journey started. Then I will start about what my current role in additive manufacturing, present company, and also I will explain about 2 new technologies, sir, which is in now emerging in additive manufacturing, and also I will explain about application later. Like if you want to explain about normal FDM or like technologies of 3D printing, also I will explain in detail, not everybody tell like that orally, like this is the process like that. But I will tell orally and in depth. Actually, sir, I have completed my BTech in 2013, mechanical engineering in JNTU, Hyderabad. After that, I joined Think 3D as a technical support. I will be handling 3D printer technical solutions like training and installation and checking the quality of the 3D printer and after sales service. And also I have done some 3D printer like chocolate 3D printer for the kids who are not interested to eat the tablets. So what we have done that we have done one FDM 3D printer for chocolate. Outer surface will be the chocolate and internal will be the whatever the medicine is there like that. So then I have developed the DLP 3D printer also for one of the mold companies for their validation of the parts and also for the production purpose. Before going for the mold, they want to check the validation of the mold parts. So for the design feasibility also they have worked. So we have developed a DLP 3D printer also around 2013 and 2014. That time all are called as a rapid prototyping only. Most of the members don't know about 3D printing. Now it is calling as a 3D printing and additive manufacturing. So after that, I worked around Think 3D around 5+ years up to 2018. So after that, I changed. Like here, I am handling only the basic printer, FDM printer, and also SLA printer, and also basic 3D scanners. Like tripod model, sir. Tripod models I used to handle technically and also commercially, and also training I have to give. So I have joined after 5 years of work in Think 3D. I have joined in Precise 3D technology. So there I am used to handle laser scanners and handle scanners in around 2018 to 2019. 1 year I worked there. So I used to update myself. So I used to handle laser scanners. That time only it is new to the market for the high accuracy. Previously, it is like a white light scanner and structure light scanner and desktop. So from 2017 to 2018, laser scanners are introduced for the handle for the small parts to big parts. So that time I used to handle, and also I used to handle the reverse engineering also. Suppose if you have any physical parts, so you don't have CAD model, I used to scan the part and I have to use for the reverse engineering. So I have to convert it to 3D model as a step file or IGS file or parasolid model. So after worked as a regional sales manager in Precise 3D, 2019, I joined in Monotech Systems. I worked around 5 years. So from there, I used to operate the machines, and I used to handle the South India for the technical sales manager. So I there I used to operate, and I used to sell the machines like production machines like laser powder bed fusion and also DUD machines from this. That time only it is releasing like new technologies, and now it is becomes a emerging technology. Then I used to sell the machines and give the solution for different applications, aerospace, defense for composite 3D printers, like glass fiber, Kevlar. It is equivalent to aluminum material. So now I'm working as a national center for additive manufacturing to develop India additive manufacturing in India, uh, to collaborate with new product development, new R&D, and also is there any specific powder which is not available in the market. We used to develop the powder, and also we have to publish to the market, means whatever the main demand in the powder which is not available in 3D printing. So we used to do the R&D also. Yes, this is my brief introduction, sir. Initially, I would like to explain about my company details, like how it is established and what we are doing. Then I will go for the what is the technologies are additive manufacturing and what is the new technologies in additive manufacturing. And also I will explain about some few means few case studies in aerospace, defense, MRO applications, and prosthetics and orthotics, and also construction. So now I am going to present my presentation, sir. My screen is visible, sir?
Yes, sir. Yes, sir. Visible. Visible.
Okay, sir. So presently I am working in National Center for Additive Manufacturing during the COVID times. So National Center for Additive Manufacturing, Government of India, they thought that this is one of the emerging technologies to introduce in India compared to other countries, which is our very low adoption of additive manufacturing as a industry so it is low. So during the COVID times, Ministry of MIT is considered as a this is emerging technologies. So they established National Center for Additive Manufacturing in India on 2021 in Hyderabad. So actually, National Center for Additive Manufacturing is the Section 8 company, sir. It is a PSU company. It is established by MIT, Government of India, and it is in Hyderabad. So with the support of Telangana government also, and also 5 to 10% with the industry partners. Suppose if customer wants some specific alloys or some specific parts to develop, so we have some industry partners. With that, with the help of industry, we will develop the powder or develop the parts. So the vision of the NCAB is to develop compressive additive manufacturing ecosystem in the country. Position India is a global hub. Yes, sir. You can see, sir, additive manufacturing industry is rapidly going for with the 170 plus global organization. You can see the right side, but India is occupies with like very less compared to other countries. You can see China is 47 to 50%. and also Japan is 30 to 32%, and South Korea is 10 to 12%. You can see all top countries compared to other countries, our is 3 to 5% only. So that government of India is thought that we have to adapt additive manufacturing. We have to do make in India for the manufacturing. So digital manufacturing. So they started additive manufacturing India to develop our economy up to 20 billion in 2023. So now we have done some projects with colleges or faculty development programs or some of the companies. So later I will later slides I will explain about that. So this is the India IM landscape. Now most of the left side you can see international brands hardware. There are multiple OEMs are there in 3D printing. You can see Meltio, EVOS, SLM are already they are in the market from last 10 to 15 years. You can see the material also voxel jet, and very few members are making the powders or wires. But compared to our domestic brands, previously it is 1 or 2 members, but recently there are 10 to 20 members are doing make in India 3D printer. Previously it is in the FDM 3D printers only. Now it becomes powder bed fusion. Now Ace Micromatic and Intech are the two brands. They are already developed the metal 3D printer and they are selling the machines. So you can see the material section, sir. Most of the brands are previously very less in India, but now one of the startup Matrix Nano, we have given the startup funding. They have established an income facility. They have developed make in India powder, means they will do the powder itself as per your composition. Suppose if you want specific composition alloy which is not available in additive manufacturing, so you can share as the composition. I need this much of percentage of aluminum or copper or whatever the composition they will make in house. They will do spheroidization here. And also for the softwares, there are so many softwares for the slicing of metal 3D printers or FDM 3D printers, and also for simulation or topology optimization. But coming to domestic brands, there are 2 to 3 members only. Intech is already developed, and AM Pravaha now still developing the simulation softwares. So AM Pravava is the software which is for the machine details. Means how if you give any part to be printed in metal 3D printer, it will give the results before only. So how machine will react, how laser will react, how's orientation will come, where the part will bend, like that. It will give the machine details. But intake is we can intake additive software is it will give only the after printing or during printing how part behaves, like structural analysis, simulation, like mechanical, thermomechanical, thermal analysis it will give. Coming to the services, there are so many members are giving 3D printing services outside or after sale services. But now domestic brand now increases up to 2025. So there are compared to other international brands, now domestic brands are increases. Drastically it is increased. Next, strategic. Our government of India, given some strategic goals to us. So we have to develop 500 plus products, supports 100 plus new startup. Till now we have given around 20 plus startup we have funded. Now third cohort is going on. Then 50 plus Indian specific technologies in additive manufacturing, and 1 lakh skilled labors and manpower. So strategic goals is India is aspiring grow is additive manufacturing. So 15,500 plus products means, suppose if they want to develop in-house make in India product which is not available in the market, we have to help the industries or colleges or any R&D also, we have to give the support to them. Hello, hello, hello. Sir, my voice is audible?
Yes, sir. Your voice is audible.
Okay. So next, sir, the 100 new startups. We are now around 20 plus startups we funded, depending on their idea, which is not available in the market. We have funded. We have a technical committee around 5 plus members. So they will validate. They will validate according to your plan. If it is a emerging technology in additive manufacturing, which is not in the market, so we will give the funding also. So next, sir, 5 India specific technologies, like this is also coming in new startup. Around 20 plus startup, they have developed new technologies which is in final stage to come to the market. So we are funded and we have given the guidance with the technical persons. We have allotted one guide for each startup, and we are doing for the commercialization also from starting to end. Coming to 1 lakh new skill manpower, means we have given the trainings, we have given the workshop for the faculty development programs all over India across around 20,000 plus manpower are skilled, and also we are giving in-house trainings for the students and also faculty members and also industries which is coming from the different industries. And also we are giving the trainings to the government officials like aerospace, defense, army, or DRDO, like that. And also we are working on 10 existing and new manufacturing sectors. Previously it is aerospace, defense, and dental. It is new, but now we have adapted like in medical, orthopedic, and prosthetics. Orthotic and prosthetic we are developed, and also we are working on the EV. So already we have developed around 2 to 3. I will show you in the coming slides. So for awareness of adoption of additive manufacturing, we are participating so many expos and we are giving workshops in industries. And also we are giving some, we are selecting different sites of the, which is in villages or which is in cities. So we are giving the faculty development program, we are funding them, and we are arranging the technical person from different industries, and we are giving the training to them. NCAP building ecosystem is mainly like new product development and Indianization. I have explained in previous slide. Skill development, we are giving training to the student, faculty, companies, and also enabling adoption of industry and readiness. So we are preparing, we are giving the training to the industries. So what they have done is, they after their learning, they will directly go for the jobs. So we are working on that also. We are tied with some of the OEMs in India. So who are in 3D printing OEMs, like 3D printing service providers. So if there any one person like skilled in our income facility, so we are giving the opportunity to some of the companies. Access to AIMS infrastructure, we have Center of Excellence in Additive Manufacturing Hyderabad. We have plastic to metal 3D printers. So in that, you can visit our facility, you can utilize our facility from plastic to metal 3D printers. So R&D and innovation, if any customer or any industry wants, they want to develop new, so we can do, we have separate funding for the R&D. So we have one metal 3D printer for the R&D itself to develop the new products. This is a sample video. One second. This video is completely about how additive manufacturing and how NCAM is established. So if this video is visible, sir? Hello?
Yes.
Okay.
Hello,
No,
sir.
sir.
No, sir. That video is not visible.
This video is not visible, sir?
Yes, sir.
So what I will do, sir, I will play later, sir.
Okay, sir.
I will play later, sir, because it has to play. One second. Yes, sir. Coming to the introduction of 3D printing. So, sir, most of the members know about 3D printing. 3D printing is the process of creates 3D product like 3D objects from layer by layer, whether it is a plastic 3D printer or whether it is a metal 3D printer, the process will be the same. Initially, it is called as a rapid prototyping, but now it is calling as a 3D printing or additive manufacturing for the mass productions. There are technologies. There are FDM technology like fusion deposit model is the basic material, basic technology. It is and also SLA technology for the injection molding part, like it will come like similar. It is we are using their resin. So coming slide, I will explain. So for this technology like 3D printing, initially we have to think about how the 3D model is. Now it is like every person are adapting additive manufacturing for their new ideas. So initially we have to go for the CAD model, which is by using any CAD softwares like CATIA or SolidWorks or any 3D model software. You can convert STL file or step file. So it will we can upload in the 3D printing software. So once we upload the 3D printing software in slicing software, so it converts as a G code. Then it G code means like for FDM 3D printing, it is a G code. For SLA, their parented software is there. So as per their requirement or their software, they will give the specific codes for their respective technologies. So the steps involved in 3D printing is initially we have to do modeling. Then we can slice into slicing software. Suppose if you are using in FDM technology, you can use Cura is an open source software. If you are using in SLA technology, Farmlabs, there are Farm is a software, and also some other software also you can use. For metal, if you are slicing the CAD model into layer by layer forms, so for metal and SLS, we can use as a magic software or Autodesk softwares are there, so that we can use. So filament based 3D printer means where the nozzle is there. So there are different type of nozzles. One is hot normal nozzle and also all metal hot end nozzle. The normal nozzle will give like 250 degrees, and the hot all metal hot end it is for the industrial applications and industrial materials like carbon fiber or glass fiber or PEEK materials. Up to 450 degrees we can go. So this process will start like once we converted it to G code, we have to give we start printing. So filament will come and melt at certain temperature depending on their materials. So it will melt and deposit layer by layer. So the base plate will be depends. It will heat because there are suppose if you use high-end materials, so it has to be stick in the build plate. So the for that we have to use build plate heating. Depends on the materials, we can go for the heating. Suppose if you are using ABS or PLA will be 210 degrees for the melting temperature. We have to go for the build plate temperature is 60 to 70 degrees. Suppose if you are using a PEEK material, it has to be go up to 150 degrees for the build plate. And also that film, the nozzle temperature will be up to 400 or 395. Second is SLA technology, where we are using material like a resin based. So where there are two types of platform system: top down approach and bottom down approach. This is top down approach. The layer will come from the bottom and it will center the laser resin. So layer by layer, the platform will move upward. So the part will be manufactured. This is a laser 3D printer like SLS 3D printer, where we are using material like high-end materials like PA, polyamide materials. Previous technologies we are using thermoplastics only. Here we are using PA11 material and PA12 material, engineering nylon material. So this process is once we give the slice to the 3D printer, the recoater will come spread a one layer of coating. Coating means, suppose if you are giving 60 microns layer, it will spread the 60 microns layer. Suppose if you are giving 120 microns layer, means you can the same amount of powder, it will spread the layer. Then the laser will come and it will scan the area where has to laser deposit. Then accordingly the laser will come and it center the powder. Then similarly same another recoater will spread the powder. Then the laser will come and center the remaining area. So layer by layer it will form the powder. But before that there are pre-production of SLS technologies. Before that we have to sieve the powder. We have to in previous technologies whatever the material is there we can reuse. Here we have to use 50% virgin powder, 15% already used powder. So that then only it will work. If you use 50% used powder and 50% reused powder, means already printed parts which is already we sieved the powder, that we have to use. Otherwise the mechanical properties are not come. It won't come, because 90 to 99%, if you are using suppose if you are using 70% of nylon material like virgin material, and 30% of used like 30% of used material, the property of the material, it will come like a high strength, like equivalent to production parts. You can use as a induced parts. Suppose if you are not mixing the powder like adequately, so 50% used powder, or 50% you use as a already used powder or virgin powder. So what happened, the parts after manufacturing the parts, there will be the parts chances of breakage or bend. So actual mechanical strength it won't come. So that's the reason we have to mix the properly up to 1 hour by using sieving machines. Then after 3D printing, we have to do the unwanted area. We have to the laser will heat around 180 degrees to 200 degrees, where we are using COT laser for the polymers. So COT laser will once we 3D printing completed, we have to wait for the cooling, because internal temperature, internal chamber will be 180 to 250 degrees. So we have to wait around 10 plus, after 3D printing 10 plus hours we have to wait. Then only once it becomes 120 degrees or 150 degrees, we do the chances of breakage are pending. So what we will do, we have to wait for up to 80 degrees or 90 degrees in the chamber temperature. Once that temperature is reaches, we have to open that part. We have to go for the sandblasting for improving the surface finish. Next, it is a laser powder bed fusion. Same, it is like a same what I explained, but here lasers are changes, where we are using metal powders. The recoater will be same like recoating the powder as per our G code, but here we are using the laser of YB fiber lasers, or solid state diode lasers, or concept lasers. There are in previous SLS technology we are using CO2 lasers. So same we load powder from both sides. Suppose we are using SS316, means SS316 we have to use. Here we are using 100% metal powder without sieving, and it is in argon atmosphere, because the laser will fall on the material, chances of fire inside the chamber. So argon we will supply to the chamber. So argon is a non-reactive. So whatever the fire is happening or sitter is happening, it won't react. So that is the reason we are using argon, or we can use nitrogen gas also. So depends on the material. Suppose if you are using titanium or copper material, we used to nitrogen gas we are used to, because this material also, as per the copper and titanium, those are high in material and high strength material are super alloys. So for that we use nitrogen material. So And after 3D printing this part, after like once we laser completed after 3D printing, we have to go for the annealing process, because here internal stresses are high. So to avoid internal stresses, what we will do once we 3D printer, we remove the powder or parts from the build plate. So we kept in the annealing process. Depends on the material, there is a cycle changes. Suppose if the Inconel 718 part is printed, we have to go for the 3 to 4 iterations, because there are this is a super alloy. It needs very chances of breakage if you are not doing the properly, because this is mainly for space applications are using, like DRDO or any space companies, mainly for the rocket engines or rockets, they are using high super alloy material like Inconel 718. So for that we have to do 3 to 4 iteration. Suppose the heat treatment process is around 1200 degrees, maintain up to uh, 6 to 10 hours. Once we completed 12 hours, again we have to cool down up to 600 degrees to avoid the stresses. So after after that we have go for the support removal process. Here we have to do post processing like grinding process or support removing process, because here supports will be there. In previous SLS there is no supports, because there is a powder act as a support. So this is the powder collector. Once we spread the powder, unwanted powder, which is we can collect from the bottom. The laser will come and sinter the powder. Layer by layer, it will print the parts. So actually, why industry adapt additive manufacturing? Because you can go for the machining product. So there is a 10 kg of like square cube. So for a small part, we have to waste so many materials to get the original product. But here we are doing layer by layer, so there is no waste of material, and also time is consumes very less. You can use for the mass productions or mass production. Now production machines are available. You can go for the 100 or 200 process for the induced purpose. Now I am going to explain about this is a new technology. I have already explained about LPBF, how it will work, but electron beam is the new technology where metal parts will get like a 100% density part. In LPBF, we can get 96% of density parts, because of the porosities will be there, and we are using the organ atmosphere temperature, and laser also will fall from the different different materials and different watts will be applied. Suppose if you are using titanium material. Suppose if you are using titanium material, suppose the laser we need around 600 watts. Suppose if you are using aluminum material, laser we need only 95 watts. So depends on the requirement, depends on the material, we have to select the laser parameters for the laser LPBF. But here we are using mostly two or three materials. Mostly it is used for the medical applications, for the cranial applications. This is a LPBF 3D printer. Already I have explained. The recoder will fall the required powder, and laser will come and deposit layer by layer, and it will form a 3D printing process. So for 3D printing, we have to go for the data preparation like FDM. But here, what we will do for EBM technology, you can stack the part by part. Suppose if your platform is 340, 340, 600, the platform up to 600 mm, you can change the height. Suppose these parts are 1000 you needed, but the base plate you are seeing that around 50 plus. So you can print a part and you can stack the parts up to 600 mm height. In EBM is possible. For laser powder bed fusion, for metal 3D printing, we can use like what are the base is there, like that only we can use. Stacking is not possible in LPBF, but EBM, the electron beam the process is same. The electron beam come and it will fall, and make the powder. One second. So once we convert into 3D, like 3D file to the metal 3D printer or EBM, so it will sinter. So before that, we have to see the powder to avoid the internal stresses and to avoid the fire inside the chamber. So once we given the parts to like sliced part to the metal 3D printer or EBM printer, it will like same, the process is same for the EBM or WPF, but the application will be different. So once we 3D printed part, so we have to unpack the material, whatever the powder, extra powder is, we have to remove and we have to sieve again and we can use that powder. But whatever the parts are there, we have to go for the heat treatment process for the relieving the stresses. Once we relieve the stresses, annealing process, we have to go for the sandblasting to improve the surface finish. There where we are using the solid blast like SS beads or glass beads for improving the surface finish. So post processing. So once we 3D printed a part, so whether we can go for the wire cut EDM or we can go for the bandsaw machine. So whatever the stick the parts are, we can remove by using the bandsaw machine. So once we remove the parts from the build plate, we can go for the improving the surface finish. Is there any supports or removal is there? So for that, we can do the post processing. And also once we post processing completed, like support removal are there, or it will came from the build platform, we can go for the sandblasting. So this is post processing technique in metal 3D printer or EBM technologies. So EBM technologies is same. The powder will be loaded both sides and the rotator will come, and here we are using cathode beam. The cathode will release the beam and it will sinter the powder, water the powder. Mainly it is used for the dental like medical applications, for the cranial application, cranial or knee joints like that. So it will get like 100% dense part and we can go for the stacking of the material. So operating environment, suppose you go for the EBM technology, the atmosphere temperature inside chamber temperature is vacuum. If you go for the LPBF, inert gas is the inert gas as a argon or nitrogen. Depends on the material, you can use the gases. The metal properties are in LPBF, higher strength and faster build and speeds, lower residual stresses, suitable for conductive materials. But the LPBF is higher precision, but surface finish is good and more intricate. It is used for the more intricate parts. So for the application, it is used for the high strength part. As I told earlier, it will give like 100% density part. So it will mostly use it for the where the part is used for the high strength, where the high pressure is applying. There mostly EBM parts will be used. Now for the application of LPBF, there are high resolution parts. We can get very high finish, high surface accuracy. We can get up to 25 microns or 30 microns or 60 microns we can go. But for EBM, we have to go for minimum 100 to 200 microns. The advantages of EBM and LPBF is, EBM is we can stack multiple parts in a single build platform, so that at a time we can print 100 parts or 200 parts. But in LPBF, wherever the build platform area is there, so for up to that only we can print. Suppose if you are printing 100 parts to 100 parts in urgently, you can use the EBM meter. But here LPBF you can use up to 10 parts. But printing time is same for the EBM and LPBF. EBM you can print 100 parts in same time, and LPBF you can print as a 10 parts in same time. So after post processing same, we have to unpack the powder. What are the parts are? We have to go for the annealing process, surface support removal process, and sandblasting process. So the main material of LPBF and EBM, typical materials are in LPBF. It is available SS316, SS174PH, SS304 are available in 3D printing, and aluminum ALS at 10 mg, and titanium is Ti64. In cobalt chrome, only one material is there. In copper, it is an R&D in most of the LPBF printers for the precision application, because it is a less, it is having less corrosive resistance. So it is now most of the space applications are doing R&D to pure copper for the space application for engine. Then EBM, mostly it is used for the biocompatible and for medical applications. The titanium and nickel based superalloys are conductive metals. Mostly in EBM, up to this year, only two materials are qualified for the uh, medical application, and FDA also approved. The surface finish of the LPBUs is super finish, very fine finish, or any integral applications also we can get. But in EBM, there is a chance very rough surface will come, because the laser diameter, the laser spot area is very high. Suppose the EBM, the beam spot dia is around 40 to 50 microns, where the LPBF is 5 to 10 microns. So surface finish of LPBF is very high, but the density, like porosity, is very like 96% we can get in LPBF. But here EBM we can get 100% density part. So application of the strength wise, you can see high, and but may retain residual stresses. So porosity will be there. So EBM is very high, and uniform properties like isotropic properties we can get. The application of the LPBF is you can use medical or dental implants, or aerospace, or automotive, and electronics, or jewelry. Medical, orthotic, prosthetics, orthopedic, and dental. You can go, if you go any dental uh, hospitals, after verifying doctor, if any teeth or any cap wants to um, cap wants to give to you, so they will ask like two opportunities. One is for ceramic crown you want, or you want DMLS crown. So DMLS crown is printed in DMLS 3D printing by LPBF or DML direct metal laser 3D printing. So mostly they will use cobalt chrome or titanium, or caps or teeth. So you can see how EBM process works. You can see here we can start the part by part up to our Z height. So in LPBF it is not there.
Hello, sir. Hello.
Hello?
Sir.
Sir,
The
sir, the
PPT is
video
not coming. The video
not
is
staying,
also
sir.
not playing, sir. The video also.
Video also not playing, sir.
Please check,
Thank you, sir. 1 minute, sir.
please check it once, sir.
1 second, sir. Now it is showing, sir.
Yes, sir. Now it's here.
Additive manufacturing offers greater freedom in design and allows for the creation of optimized parts that are not constrained by the limits of traditional manufacturing. RCAM EBM has the unique ability to tightly stack parts within the build in order to increase productivity. An optimized build file is sliced and loaded into the RCAM EBM system. Following this, metal powder is loaded into the machine. The build chamber is then closed and a vacuum is created to ensure a clean, controlled environment that allows for the processing of reactive material. Next, RCAM EBM's powder layering system evenly distributes a thin layer of powder on the build area. A powerful 6 kilowatt electron beam heats the powder bed to optimal ambient temperature and then proceeds to melt the powder. First, contour melting and then hatch melting. The electron beam unit generating the beam contains no moving parts, allowing for extremely fast and accurate beam control. The built environment is kept hot, reaching temperatures exceeding 1000 degrees Celsius, resulting in no residual stresses and allowing for the processing of crack-prone materials. As each layer is completed, the build is lowered and a fresh layer of build powder is raked over it. This process repeats, growing the build one layer at a time. When the build is complete, the tank is extracted and the RCAM EBM machine is prepared for the next build.
Hello. Sir, my PPT is visible now, sir.
No, sir. The PPT is not visible, sir.
Now, sir.
Yes, sir. Now it's visible.
Okay. Now the hybrid manufacturing, sir. Now I previously I explained about EBM, how it will work, like what is the post processing we have to do. But in hybrid, you can see nowadays vehicles are coming like a hybrid, like petrol and EV. So similarly, hybrid manufacturing, where we can install the probe, like laser of head in. If you have old existing CNC machine, we can use the probe head. There is a place of beside the CNC root probe. So we can install that probe into the, like you can see here, there your CNC tool is there. So beside we are using same table. Suppose if the table is 500 or 500 into 600 L into B. So that existing CNC build platform only here we are using. So initially what we will do, whatever the G code we are giving to the CNC, and here we are using only the 3D printers control systems. We will install the 3D printers control system. We can upload the whatever the file we want. So as per that, we can give the coding to the 3D printer, okay, to the CNC. The whatever the 3 to 4 layers as per our program. Suppose I want to print 10 layers of a 3D printer parts. So 10 layers, the probe will come and print layer by layer. And remaining 10 layers I want to finish, means this probe will come and finish, like give the machining, and we can get as a 3D printed machine part. So here this is a hybrid tool path, sir, metal 3D printing. So we are using the same build plate of existing CNC machine, whether it is a 2000 from 2013 CNCs. It is we can install the hybrid probe to the existing CNC machine. So once we done the 3D printing, you can see here 3D printed part. Here we are using our powder or wire form. So layer by layer it will form. Then we can get the CNC machine. Suppose once we printed this part, we have to give the program that go and machine the existing part. So this probe will come and remove the unwanted area, and as per the step model or as per the CAD drawings which we are given. So accordingly it will come, like we can use as a end use parts. This is a setup. So why the hybrid manufacturing is needed? Suppose in 3D printing, some of the customers need high precision parts which are not possible to do in CNC machine, even in 5-axis machine also. So what we will for that type of applications, suppose this is a horse machine, the horse tool is here, the beside we have head, laser head we have installed here. This is the control system. Previously, along with the CNC machine, it will come like a control system. It converts to the G code. But here, once we install the probe, only Meltio engine software is there. This software only we have to operate with CNC as well as 3D printer. Suppose if you want to use only CNC, so you can use CNC the software. But if you want to use CNC with 3D printing, you have to use the 3D printer software. So here we can get 100% dense part, but the surface finish is very high. Surface finish means like roughness is very high. Up to we can get up to 40 to 50 RA value. So we can get the 100 to 200 microns in LPBF, but here we can get 500 microns or 1000 micron. We have to go wherever the extra extra material it will come. We have to go for the CNC machine. So CNC machine will go and remove the unwanted area as per our CAD model. So why we need a hybrid manufacturing is sustainability significantly reduce the carbon footprint of the other business. Suppose if you go for any 5-axis machine which is not feasible to do in CNC, in 3D printing we can do it. And production flexibility, design freedom, is there any critical part also we can do in 3D printing. And quality is like you can get a machine part. Here we are getting like a machine part with a high density, and here material wastage also very less. And suppose in CNC if you go for any part, that printing time means the machining time is, and we have to go for so many iterations. Here in 3D printing, single iteration without support, we can get CNC like hybrid, like CNC 3D printing with machine depart, we can get it. So the response time is like printing time is very less. I will show you coming slide. Some of the parts we have printed in hybrid manufacturing in DED. So these are the solutions. There are so many products are available. So I'm Meltio engine CNC integration for hybrid manufacturing, repairs, and future addiction. I am going to explain. I have explained about this. This is normal DED machines. Here probe is there. The laser will simultaneously it will come, and all laser fall in a single point. That point will come the material, whatever the material we are loading, it is same like it will work like a FDM 3D printer. The nozzle will be there, the laser will come. Here we are laser is 1.2 kilowatt laser will come. Coaxially it will come like from this side, or three lasers from this side, three lasers from this side. So all the lasers will come in as one point, and it will melt the whatever the loaded material. Suppose if you are loaded any SL316 material, the wire material loaded by extruder motors, where the material will come, and wherever the 6 lasers are falling in a one place, that area material will melt and deposit layer by layer. This robot for the bigger parts. So the benefit of a wire-based process is we can get zero metal wastage, and we can get very fast compared to CNC, and the cost of the material also very less, because here there is no wastage of the material, and it is readily available in the market, and the productivity is very fast, because in CNC they are taking one week for the production, like machining of one component. Here we are getting like 1 day or 2 days. So here time is reduced and the productivity has increased. So benefits of hybrid manufacturing is the material scrap. Suppose if we have already CNC wasted material, that way we can make it to wire, and we can use that wire. Here we are using 1 mm diameter of wire or 2 mm wire. So depends on the wire, also depends on the wire diameter. We have to adjust in the slicing software, in hybrid manufacturing. So if you are using 1 mm means we have to select the 1 mm diameter, we can load the 1 mm material. tool where is here production. Suppose if your tool is already repaired. Suppose if you are go for the any injection molding tool, that mold is repaired for user around 5 years or 10 years. That mold is wear and tear down, like like broken. So where we can go, that area we can fix that area, and we can go for wherever the unwanted area is broken part, we can join also in 3D printing. Like it is like a welding process. And working capital, replace inventory of cutting tools. You no need to spend cutting tools in-house, because whatever the tool you needed, you can use as a digital inventory, like a CAD models. You can wherever whichever the part you needed, you can use that CAD model, upload into 3D printing, you can get the 3D printed part. And as I told earlier, it is giving you excellent mechanical properties, because it is 100% density part. We can go this part mainly used for the aerospace and defense application for end use purpose. You can see the LPBF machined part. Previous it is we can get like a LPBF 3D printed part. So once we do the machine, once we do the machine means we can get this quality. In hybrid also we can get this much this type of part only, but the surface finish is very less, because it will come like a very less. Once we done this part in hybrid manufacturing, we can get the output like this. But here get in LPPF we can get a 96% density. We can't get 100% density. Here we are getting 100% density with hybrid manufacturing. The main real world applications which is already used in industry in different countries or different applications. So there are so many applications are used. Have taken few case studies already. It is successed, and also few case studies in a different applications, like aerospace applications. Have taken two case studies, automotive or medical or construction or consumer goods. So the medical applications are mainly used, previously or 2010 or before, 3D printing is not there in India. So they will use general. If the patients are for the baby, they have to use standard orthopedic or bones or knees. For bigger who are like men's who are already 20 plus age, so they have to maintain the same um, uh, same hello same like general patient specific tools. So but once we 3D printed come, whichever the patients are required as per the patient specific, we go for the MRI scanning. Once we done the MRI scanning, whatever the slides are there, that MRI scanned object we have to convert into STL model or step model. Then we can go for the 3D printing. Next is digital dentistry in medical application. You can go, if you go any digital like dental hospital, you can get DMLS crown. Now most of the dental labs are using digital dentistry. And also for aligners, patient specific aligners also we can go for using 3D printing. And 3D printed implants and prosthetics. Yes, there are road accidents are going on. So patient in market, patient specific or implants are not available. So what they are doing, they are taking MRI scannings or by using 3D scanners. One of my friend lost legs in their in accident. What we have done, we have scanned the left leg. We have scanned the left leg. We have converted to right leg in 3D model software. We have printed that part and we have given to them. It is now working from last 5 years. He is using the leg, 3D printed leg. Bioprinting for the just for visualization before going for the surgeries. Bioprinting are using surgical planning, and before going for the surgical also. Suppose if you have any teeth problem, if you go for the teeth implant, so they have to go, they have to take your impressions by using some glue. With that, you can scan that model. That model, we have to go for the 3D printing in basic 3D printing technology like FDM. So that part they have to see, they have to fix the teeth, whether the area is perfectly or not, whether the drill we have to go for approximately or not, because the bottom side there is a nerves are there. So if the drill will disturb the nerves, means the total jaw we have to face the severe actions. That's the reason before going for the any surgical planning, they go for the prototyping. They will practice before the surgery, then they go for the main surgery. So medical breakthroughs, custom implants. So this is a patient specific complaint implants. This is a hip implant customized for the one of the patient in India they used, because previously this type of parts, this type of implants are not available implants. They maintain for age to age, like general implants are there. But once 3D printing comes, whatever the uh, patient specific implants, they go for the metal 3D printing for like biocompatible material like titanium is there or cobalt chrome is there. So with that, for previously we have to wait for 1 week or 10 days. Once we patients are come, once we scan the MRI scanning, so we can within 2 days we can go for the patient specific implant for the surgeries. And surgical guides for showing the students or for validation purpose, we can go for the surgical guides. So dental application, you can see there are so much of implants are there, are so much of jaws are replacing in accidents. There are teeth also there. Wherever the caps you needed, they will same. They will take a impression from your teeth. If you want any teeth, they will scan the teeth model. They will convert as a step model. They will print as per the your teeth required area. So dental application already it is in huge market. Now most of the dental applications are using either investment casting process or metal 3D printing process. We can get a metal crown. For the education tools, 25% of reduction in operation theater before going for the surgery planning. So they will analyze where the nerves is there exactly. So accordingly, they will plan for the surgery. It is very easy because previously this type of technology is not there. So they will take 5 hours or 10 hours. Now the technology change. So 10 hours surgery, once we going for the preparation, so 25% of the time is reduced. In previously 10 hours, now it becomes 2 hours. So precision also increase, improve training and outcomes. Suppose one of the striker company in India, orthopedic implants, this is a patient specific implants. So if you go, you can see the structure here. So this type of structure, it is any technology is not possible except 3D printing. So here supports are there, like hexagonal supports type is there. So this area we have, they are 3D printed as per the patient specific implant. So here we can see biocompatible lattice structures are there. The lattice structures is here. Patient specific customization. As per the patient only we have customized. So process is same. That my MRI scans, they want to convert into model, then we can go for the 3D printing. And unprecedented design freedom. See this type of parts, we cannot do any machining or any process. But in 3D printing, this type of lattice structures, we can print this part. We have printed in around 2 hours. It is printed, and we have after printing we have go for the heat treatment. Like one day, within one day we deliver. This striker in Delhi. Yes, sir. This is titanium spinal implants. This part you can see it is a FDA approved. In previously they go for the welding process or milling process. There are multiple process they have to go. But once we 3D printing completed, in a 2 to 3 days we have delivered this part. And this is already used in patient specific. Is now using. And aligning technology. So now it is trending like a aligning technology. Most of the members are now advertising like aligning aligners, but how they are using aligners is the main scanned object. They go for the 3D printing, 3D printing. Then they go for the lamination process. I forgot that. Yes. Actually, once we 3D printed this mold, they go for the thermo forming process, biocompatible ABS or PLA, a light metal sheet. The sheet will fall on the mold, 3D printed mold. Then due to vacuum pressure or mechanical pressure, automatically the whatever the heated thin sheet, it fall in the mold, so it will absorb. So as per the patient specific allowance we can get for the mass production. Here for aligning technologies, we are using 3D printed part as a mold. Metal Jettil technology polymer. Benefits are 5 lakhs custom aligners a day. So thermoforming they will do once we printed 3D printed part in a any technology like metal jetting or SLS or SLA technology. So with that mold they will go for the thermoforming process. And Johnson Johnson, other company called Johnson Johnson cranial implants. So if any persons are any accidents happen, is there any like issues is happening for the head? So what they will do, whatever the screws are there, the small screws are there, that is very difficult in metal 3D printing. So what they have done is uh, very difficult in CNC process or any milling process. So what they have done is same, that whatever the model we have given, we printed and we have given to the customer, patient specific customer, in titanium or cobalt chrome, depends on the customer requirement. So it is already used for the one of the child, small child, he fall during the some accident. So here the time of the surgery is very less. Already he is prepared before going for the surgery, and precision is accurately it will come. Then now most of the members are facing custom foot, orthotic and precision comfort care. Most of the members are, suppose in India, most of the members are diabetic. So for walking, there are so many issues will come. So suppose here, if you are getting actual tendonitis or arc pain or bunnies or heel pain, heel spurs, this is now new technology. As per your foot, as per your foot, they will scan your foot, the base, uh, they will scan this food like this. So they convert into STL model. We have printed so many parts for patient specific, for orthotic and prosthetic. This is the sample parts we have printed in-house in Hyderabad. So we have done so many customers as per the patient specific. Suppose you can see here pregnancy and food. As per so this lady also, here they came and we have printed some parts. Here what we can here what I do is, this is real case application one of our startup is doing in India. So we have funded them. He's already orthopedic and he's a orthotic and prosthetic doctor. So he already working on it. Coming to the other application, energizing and tooling, if you see this type of parts is very difficult in CNC. If it is possible in CNC also, for turbine blade, they want to do for minimum or 1 month it will take. This part one of the customer is Siemens gas turbine blades. They printed in nickel alloy Inconel 718 in a 1 week. They have printed and they have given to the their end customers. Here is the benefit is here we are using like DMLS LPBF process with 96 to 98 parts, 98 parts of the density of the part, and here we benefits are 30% better cooling efficiency. This part is having like high pressure and high compression because it will use like a continuously. So for that we have done some simulation analysis, thermal analysis, thermomechanical analysis before going for the printing itself. There are softwares like simulation softwares. So we have to go for the simulation before printing, whether actual application it will work or not. So next is customize and lightweight ready fast. Manual 2 to 4 weeks it will take. For CNC 3 to 4 it will take for this part, but 3D printed part within 48 hours we deliver. Next, Boeing environmental conductor tests. See, you can these C parts. Suppose Boeing is 788 Dreamliner demonstrating of additive manufacturing for critical load and modern aircraft. Here, what they have done is previously part is like this, but what happened? This part is a bit weight. So in CNC machining, what customer done is they have done topology optimization without changing the applications. It will like a same previously part, but weight will be reduced. What they have done is the infill is they have changed like previously it is solid. Now they have changed like a hexagonal or triangle or rectangular inside the part, so that the weight of the parts are reduced. So for CNC machining, they go for the one part is 3 days, but in 3D printed within 3 days, they have supplied around 10 parts. Here you can see weight reduction of the parts. Suppose that it is an aircraft, so the weight is matters. If the small part is weight reduction means the efficiency is increased. And this is a complex geometry. Not only this, any complex geometries also you can which is not possible in CNC, we can go for we can print in 3D printing and assembly also. Some of the aircraft components, engine parts, fuel nozzles, LEAP engines, they have already tested. Turbine blades, just now I explained. Combustor liners, Pratt and Whitey in cobalt chrome, Pratt and Whitey in Bangalore company, they are already doing turbine blades also. And heat exchangers, Honeywell USA, they have tried and they have printed heat exchangers. And bearings and seals for ceramic composites and binder jetting, they have already used. Suppose in CNC machining, you want specifically like for robotic application also, you want specific jigs and fixture to hold the part. So for small design changes in their model, it is very difficult to go for the mold. Then making a part is very difficult. What they have done is they have printed 3D printed part, and they have initially tested in FDM technology carbon fiber. The carbon fiber nylon is equivalent to aluminum material, the same equivalent strength to aluminum. So here they reduce the time of around 50% reduction and faster. Cost is very less because if you go for aluminum, that cost is very high. In carbon fiber FDM technology, the cost is 50% reduction and also fast. Suppose this part, same part is they want to go for the mold, and mold is taking it will 1 month time for CNC or any injection molding part, but it is in validation stage. If after you are converting into going for the mold, is there any deviations also, it is very difficult. But initial stage they are used 3D printed parts. Any design changes also they have done it, and after that final they have assembled it. Once this assembly is completed, they go for the mass production, thousands. So here time is reduced, their cost is reduced. See here the structures of the heat exchanger. So it is very difficult in CNC machining. So the benefits of this is this is printed in stainless steel material in SLM technology. So here the 40% smaller and 20% are more efficient, because here time is very less, and if you go for any other technology also, any other CNC or milling you can go, these parts are very difficult, and if it's possible also it will take like months. So they have given the LPBF, as per the LPBF are designed for additive manufacturing standards. They have designed it, so they get the benefits. So this is automotive applications. Automotive application in India or world, most of the members are using for the prototyping, validation, assembly, or for initial stage of testing. So Ford is the company, before launching the vehicles, before going for the final, they will go for the prototypes, whether the part is fixing or not, whether the part is looks good or not, whether the part is feasible or not, whether the part is attractive or not. As for that, they will go for the design changes. Then the one prototype will be done. Then all the parts are finalized, designs are finalized. They go for the high pressure die casting or injection molding. Second, custom parts. Here we can make customized parts, customized designs, and customized parts we can make, and we can assemble in the uh, automotive sector. Not only bikes or cars, also on demand we can manufacture. Automotive more is quicker product development. Now Tata Motors are doing here, Maruti Suzuki is doing, Royal Enfield is doing. Any automotive company, not only automotive, EV industry also in bikes. Before going for the mass, before launching, they want to test the prototype. So Ola also they are using. Ola also they go for the prototyping initially, or either also they go for the prototyping initially. Once the design is final, they go for the final production. So for as I explained before, Ford or BMW or these are the prototypes before going for the mass. Like just for the feasibility, they have checked. Automotive applications case study is Bugatti titanium brake caliper. Suppose this, you can see this part. There are so many curvatures, so many angles, so much of thickness is less. It is a brake system. We have to sudden brakes, we have to apply sudden brakes, so it has to withstand. So previously this type of parts, they go for the high pressure die casting part, but that it is for high pressure die casting, they have to go for the mold. Once the mold is completed also, whether the part is not properly assembling, so they that mold cost is very high. It will take like 3 to 4 months for a high pressure die casting part. So what they will done is, they have initially tested by using 3D printing. So they have directly used, because of that, the first largest 3D printed caliper, and the weight of the part is very light, and post processing also taken very less. Second, piston rods, the same application, it is for lightweight and better fuel efficiency. 3D printed pistons, Porsche has used. Same machining components are high pressure die casting, they have to go, but due to new technology, they have explored new technology, so they get the benefit of 10% more power, fuel efficiency, and more mileage. And you can see the images here. BMW Group ergonomic assembly years, custom grips. The robot need or depends on the part. They want to change the custom grips. Faster production. If you go any conventional manufacturing process, it is not immediate. You can get the parts. In 3D printing, you can get custom faster production, and improve worker comfort. Suppose when the robot is working, manual interaction is very high previously. Now once 3D printed comes, whatever the part, any specific parts you have to go, you can directly use that 3D printed part as a end use parts. this is the tapered bearings which is used for the BMW braking system. So where the very high pressure is applying here. So this type of parts are very difficult in any other technologies. The bearing needs to withstand high temperature, high pressure, and high compress also. So initially they have tested in 3D printing. So they have tested and they have validated. They have used for the bearings. So now they are using. They have in-house machines of 100 plus in BMW company. Directly they are printing 3D printing parts for the BMW customized BMW cars. Here you can see the benefits. Here there is no tooling, there are no rotations, multiple rotations for this type of component. If you use y-axis machine, we have to go for the 3 to 4 rotations. Means around 3 to 4 days it will take. In tooling, this part you can get in 3D printing, you can get in 1 hour or 2 hours you can get. Maximum post-processing it will take like 2 to 4 hours. Then you can get the physical component as it is. Here your cost is here your cost is very less. You can get this part in a 1 day, 1 to 2 days. So here time is reduced. So you can get the you can print more parts in a 3 days. Suppose 3 days, if your build platform is very high of your metal 3D printer, at a time you can print 20 to 30 parts. So in 3 days you can get 30 parts. In tooling, in 3 days you can get 1 part. So here water pump motor sports car. So previously it is there like that. They go for the high pressure die casting, but using aluminum SLM ALS at 10 mg, this printed using SLM technology. Then this suspension mount bracket. You can see any vehicle suspension is very important. We can get more pressure and more pressure and more compressor. So here they have tested with titanium material. Titanium material is very strong. So the mounting brackets and drive shaft sliders, Red Bull racing car using lens, resulting in a 90% material reduction. Previously this part is other like solid type. So what they have done is they have done simulations, they have done topology optimization. Topology optimization is nothing but the whatever the pressure it will withstand as per the previous, and mm, whatever the temperature it will withstand, whatever the load it will withstand, that application it will show. But wherever the unwanted area is there, the software will remove the unwanted area and it will reduce the part part weight. So intake brake system of automotive engine. You can see this is the mold and the high pressure die casting. It will take lots, like mostly 1 year or 2 years also it will take. But in 3D printing, we can get it in within 1 month. We can print and we can use this all they have tested. An automation part produced using EM. This part is the cover of engine in two-wheeler. So the engine cover, before going for the production, they validated in metal 3D printing. They have assembled it. Then they go, once the design is finalized, they go for the high pressure die casting process. Successful manufacturing product in automotive industry. There are this is normal. We have I know as per the industry, but there are multiple parts already printed all over the globe. They are already using, but as per industry knowledge, these are the parts. And also I have the list of some of the part names in automotive industry or aerospace industry. Or suppose engine brackets are printed, turbochargers are printing, housings are printing, exhaust manifolds are printing. Because we all are NDA parts, it is not available in the market. So as per my knowledge, I have list. Piston crowns are printed, cylinder heads are printed, gearbox housings are printed, brakes are printed, heat exchangers are printed, brakes calipers are printed, lightweight body panels are printed, interior trims are printed, camshafts covers are printed, reed valves are printed. So all are 3D printed. Now most of the automotive sectors, they are using for the initial prototyping using 3D printing, validation using 3D printing, before going for the mass productions or 3D printing. If spare is not available, that part also they go for the 1 to 2 quantity in 3D printing. Aerospace and defense, now most of the metal 3D printing companies are using metal 3D printing in aerospace defense, or some of the composite 3D printers also using for the drone applications or space applications. So here mostly aerospace and defense, they use for the functional prototypes for the end use. Some of the companies are using for the tooling. Some of the use for the lightweight parts. Lightweight parts means you can consider drone. Drone parts are, we need lightweight parts, and space application we need lightweight parts. Here the benefit is, for low volume production we can go for 3D printing instead of go for the conventional manufacturing. Here 3D printing, without changing the design, we can wherever the unwanted area, it will remove by topology optimization. It is advantage. Material efficiency, whatever the material they are using in conventional, also we can get material efficiency in 3D printing. Part consolidation, before going for the part also you can use we can use as an induced part, and you can do the part consolidation. If any part is repaired, suppose any part is broken during the usage of the aircraft or any drone, so that part immediately we can print. If you have solid or step model, so immediately we can print that part and we can use. So aerospace applications, engine components, structural parts, space application. Here, space applications, most of the in Indian startup, you can take Skyroot Aerospace or Dhruva Space or Agnikul Cosmos and Spatric Aerospace. There are Indian startups, they are already launched 3D printed rockets in last 2 years in ISRO. So now they are doing R&D on other series of space. They are now printing, maybe they are doing R&D in copper or Inconel or titanium engines for long life. So you can see structural parts. This type of structures, cooling channels, is very difficult in any technology. In this, we have to maintain the design for additive manufacturing standards. In LPBF, we have to maintain minimum 0.8 mm wall thickness. If the gap is 0.48 mm wall thickness, so we can print any part, any critical part in 3D printing. In aerospace and defense, most of the industries are, they will use for the MRO applications. For the maintenance, M means MRO industries. Here, maintenance, is there any parts are needed maintenance for the spare parts? For the maintenance, they will use repair. Suppose already part is broken, by using DED technology, we can, wherever the part material is removed, that area we can use for the repairing of the spare parts. Or hello, my voice is audible, sir?
Yes, sir. Your voice is audible.
Okay. So mostly the aviation sector now, they are using metal 3D printing for the space applications. Okay. Aviation or more applications, mostly that you can see any aircraft for consuming less fuel, giving long travel, we need lightweight structures. So whatever the parts are there, topology optimization we have to do, because topology optimizations are, the part will be used like a same part, but it will reduce the weight of the part. And fuel efficiency, if your weight is reduced means automatically fuel is efficiency is more, it will give more mileage. Engine parts, some turbine blades are nozzles, so we can print in a 3D printing, and it if the part all printed means it will automatically enhance the performance of the lifespan of the engine. So spare parts, any on-demand spare parts also we can print if you have CAD models without depending upon the conventional manufacturing. So aerospace applications, LEAP, this is LEAP fuel nozzle. Previously, this part is very big. They have to go for the milling process, welding process, joining process. They have to go for conventional process like 20 parts. So here, once in we have done the simulation, we have converted to this part as a single part. So we have printed like a single part. Here the we have used the topology optimization also. Here the benefits is 25% of lighter. 5 terms are durability. It is increase the durability, and it previously it is a 20 parts. There are assembles are 20 parts are assembled here, but now 3D printed one part. So the advantages is the time is reduced, cost is reduced. You can see Indian defense or drones or turbine blades. So now it is Make in India is going on. So most of the drone companies are working on drones for the lightweight components and using the carbon fiber or glass fiber or Kevlar or high strength glass fiber or high temperature glass fiber. So in space companies also. So before they go for the prototyping of the part, then they go for the validation, then they go for the basic is prototyping will be done in FDM technology. Validation will be done in SLA technology. For the direct end use part, they go for the MGF technology, that is jetting technology, or SLS, selective laser sintering, which is nylon filled glass fiber is available. Or there in the market there is composite 3D printer also there. So that with that material we can use directly end use part. We have some printed lot for drone application, for different space applications. Some of the canopies we printed, some of the top covers are we printed, some of the load areas are printed. So with that, they don't depend in other manufacturing process. Instead of that, they are getting within 2 to 3 days, and they are making that prototype, and they are going for the market for selling their demos, their drones. So next is Airbus. This is a bracket they have printed in scandium alloy. So here previously they go for the CNC, that wastage of material is there and the weight of the part also very high. What they have done is, this is the topology optimization done part. See, these two are fitting in one area, same here fitting is there, same applications, same holes are there, but the wherever the this area is removed and the strength of the part will be same. So add additive manufacturing aerospace bracket after topology optimization, how this part is working in a bracket. Similar same thing here. The application is same. The performance is increased because of the lightweight. So here benefits of the benefits is 40% weight is saving is there, and reduce the material waste. Here we have done topology application without changing any applications. It is used as a end use parts. So aircraft button, it is printed in hybrid manufacturing. This is a 3D printed DAD part. Once we 3D printed this part, this is CNC machined part. So previously I explained about hybrid manufacturing. Initially we can get this part, then whatever the code we have given, we have to go for the CNC machining. So we can get as a 3D printed hybrid part. So here get 100% density part. You can use as a induced parts. And here this is a 3D printed part, and this is machined part. So this type of parts very difficult in CNC machining, and also it will take so much of time. So drill bit need high strength for drilling the holes. And 3D printed lattice insoles. Previously, I explained about patient-specific lattice insoles. So this type of lattice insoles are difficult in any other technology. So here, 3D printed lattice structures printed, and it is used as a induced part as per the patient-specific needs. Here you can see the design freedom. Any other conventional process, this type of flexibility is not there. Some of the parts printed, this is the printed part in DED and machined part. So this is the glass mold core. This weight of the part is 6 kg. This printed in 24 hours. This cost for the printing is 24 hours. This part is around 10,000 rupees. So if you go for conventional, it will take around 10 days time. The cost of maybe less, but in that 10 days time, with 3D printing, you can get 20-30 parts. So watch bezels are there. So the weight of the part is 29.22 kg. These all parts are printed in 5 hours. That all parts are cost is around 3,000 rupees. So this is a combustion chamber. This is a combustion chamber. You can see the cooling inside. The whatever the fuel is there, it will go and it will cool the chamber. This for this critical part, you can see the chambers area inside. Zigzag way is there. So this part weight is 4.88 kg. This part is printed in 27 hours. The cost is around 10,000. So this part, if they go for any conventional machine, in 24 hours they won't get. Some of the blades they printed. This is printed in 26 hours in SS316. And this printed also, this type of overhang, any other technology, any conventional process, the wastage is high, then it will come as a support. Here the curvature spherical tag, so it is printed in 81 hours, means around 3 days. 3 days it is printed. In any other technology, it is very difficult. This cost is around 40,000. This cost is around 3,500 or 4,000. This cost is around 50,000 or 20,000. So this is machined part, naval propeller Meltio engine robot. So this diameter is 600 mm diameter. In India, no LPBF 3D printer is there up to 600 mm. But as I told earlier, CNC, if the CNC build platform LN to B 1,000 is there, means we can get 3D printed machined part 1,000 mm parts also. So some of the engine manifold printed in DED. So it will take like 19 hours without supports. Any other technology is very difficult. It is 9,500. You can see all the parts. If you go for any conventional machine, the cost is very high, time is very high, but 3D printing cost is very less. You can get as it is part, as it is mechanical properties. So here brazing nozzle is there, bagging nozzle. They printed in 6 hours. Gas turbine fan is there. They are printed in 3 hours. And airflow cooling blade, aeroplane cooling blade is they are printed in 6 hours with 1,200 rupees. So the aerospace and applications, there are so many areas they will use replacement of suppose on-demand production is there, such as brackets, clips, houses, covers, knobs, and other small, medium-sized components also you can do it. Prototype of mockups, before going for the final design, they go for the prototypes. You can see the drone application, one of that, space application, and fitment testing also they will do. Tooling and fixtures for material holding devices. Different machine having the different fixtures and different tool, and different depending on the part also we have to do tooling and fixture. For machining it will take so much time, whatever the as per the specific part required, as per that we can go for the 3D printing part, tooling and fixtures, duct and houses, wherever the duct and houses are there, intricate geometries are there, so we can print that part. And composite repair patches, already is there any repair parts already done, any repairing also, they are facing some repair also, we can use repair parts by using the ED. And the interior components, cabin fittings, seat parts, tray tables, storage components, and decorative element, they can manufacture easily by using 3D printing. Spare part production, on-demand spare production. Now most of the aerospace and defense and army are any all are adapting additive manufacturing, because if they go for the any war or like that, already Ukraine or Russia, they are using 3D printed parts. So in war they are installed 10 to 20 metal 3D printer, which part is broken, immediately they are doing reverse engineering by scanning the object, converting it to step file. The step file is going for the 3D printing. Once 3D printing, they are using for the spare part. So major MRO in this companies in India, Aeroworks India Engineering Work, GMR Aerotechnic, they are using 3D printing. Aviation, see, you can see all are aerospace. Taj Air Limited, Air India Engineers, it is available in internet, but most of these are available. But beyond this, there are multiple companies, they are not showing outside, but 100 to 200 plus companies are using 3D printed components, but they are as per their NDA, they are not coming out. So this is 3D printed gauges. This is 3D printed part. Once we 3D printed, we go for the machining part. So this is the machining part. Airbus is experienced with 3D printed plastic part, metal brackets. One plastic parts means there are process of investment casting. They will get wax pattern. Once we done for the wax pattern, we have to go for the whatever the material. Suppose you want is metal, titanium or Inconel. So for mass production, you can pour that material in the wax. Then the wax will be removed. Exact metal part will come. Once we have to do polishing and we have to go for polishing or improving surface finish or sandblasting, you can get the mass production of the parts. The aerospace, the key takeaways of aerospace is mostly aerospace, they will go for the space applications. Here weight reduction is very main criteria, but by using topology optimization, weight reduction is done already. Part consolidation also we have done. Automotive applications, performance gains, customization as per modification as per the model. If you change any new product developments also, you can go for new product development. Medical, you can see patient specific solution already done. Energy tooling, cost and time and savings. Comparative benefits, aerospace is, you can see waste savings are 20 to 40%. Cost reduction is 30% reduced. And hello, sir, my voice is audible, sir?
Yes, sir. Yes, sir. Audible. Yes, sir.
Okay. Here you can see the defense applications. 15 to 35% of weight is reduced. If the weight is reduced, means the efficiency is increased, life is increased. Cost of the part also it is reduced. Previously it is 1 lakh, it is comes at 25,000. So 25% of the part is cost is reduced. Lead time also, for going for any conventional or any manufacturing process, it will taking months, and also approval it will take more than 1 year also, some of the aerospace and defense applications. So here 3D printed part, like time is cut by 70%. Automotive, previously they go for a high pressure die casting process, there is no validation, they want to go for manually. But once 3D printing comes, they have every part, they have go for 3D printing, they are assembling that part, they are validating that part, the design. Once the final, they go for the their conventional process for the bulk. Up to 1,000 parts we can go for the 3D printing, but for mass production we have to go for their conventional process. whether the casting they will go, whether the high pressure die casting, therefore going for the injection molding. Their respective manufacturing, they can go for the mass production. Medical, here weight savings are not available, but the cost is reduced because as per the patient specific, and the time is also reduced because they will prepare before going for the surgery. So the time for the surgery is reduced. And industrial applications, fixtures, previously conventional means it is very difficult for the fixer for holding the material, but specific design, we can go for the we can print in the parts in 3D printer for the material holding. The cost also reduced, 50 to 80% is reduced, and the lead time, delivering of the lead time is reduced. Now the construction, now most of the emerging is construction also. So all are printing residential houses, commercial houses, infrastructure projects in various countries. I have taken few examples of our Indian OEMs are done. So this is 3D printed post office in Bengaluru with the help of L&T Defense. This 3D printed post office in Bengaluru with the help of L&T Defense, they have printed this part, this post office in 43 days in a 5 to 10 lakhs price. Compared to if you go for the conventional, it will take minimum 3 months, 2 to 3 months approximately. But the cost also it will go for the 20 to 30 lakhs. But 3D printed part, 3D printed this post office, they are printed around 10 lakhs, 10 to 15 lakhs in a 1.5 month. The properties are same like a concrete. This 3D printed villa is printed in Pune, Godrej Industries. They have printed this part around 120 days, maybe 3 months they have taken. So concrete printing. So it is a robot type printer. The concrete will be loaded. It is work like a FDM technology, fusion deposit model, layer by layer, it will print and get a part. Once we 3D printed, we have to go for the improving surface finish. This printed is around 120 days. It is around 2200 SFT square yard. So if you go for any conventional process, it will like normal routine construction process, it will take minimum 1 year, and the additional like plastering all are, it will take like a 1.5 year. So this they printed in around 2 months. The plastering all are, it will take like 3 months. It will take 3 months. And also the cost of the part is around 60 lakhs. It is printed in Pune. This temple is printed by Simply Force Telangana. It is in Siddipet. They have printed this fully temple in 70 days. But whatever the idols are there, they have not printed in 3D printing. They went for the mold. But the infrastructure, what they have done is they have 3D printed. One of the company called Simply Force Technologies, they have printed in 70 days. This is Madhya Pradesh Army. They have printed this part, this whole building in a 4 months with the interior company called as a Simple Force company for their army, for their office, for sitting their office. And also the whatever the concrete they are using, as per the what generally we are using cement and sand, the similar properties, similar strengths, and also it will give more life because the structures they are printed like a locking type structures. So life of the house also it is increased. This is one of the company, they have fold design from the Pune. What they will do is, the company is interior design company. If you go anyone in Mumbai airport, most of the aesthetics parts, most of the interior design parts, all and most of the engineering part also for the um, looks, for the looking interior parts. You can see this type of parts in the Mumbai airport. What they will do is they will print 1 meter to 1 meter part or 2 meter to 2 meter parts. They will join. After that, they will join. They will do the post processing like painting, putty or coloring. Then they will install in their respective areas. So it is whatever the construction company I have shown, all are done that in India. Yes, sir. Is there any questions? You can.
Okay, thank you, sir. Dear participants, if you have any questions, ask to him.
Yes, good evening, all the participants. If you have any questions, you can put in the chat box.
Sir, good evening, sir.
Good evening, sir.
Sir, this is Professor Malleshwar Rao, sir.
Sir.
Yes, sir, just now you have shown that villa 3D constructed in Pune. Sir, what sort of materials they use, sir, for that? Yeah, this one.
They are mixed with concrete, some glue type of gypsum, concrete and gypsum, and some type of chemical for the bonding, sir. 3 type of metal they are used.
Sir, is it a fire resistant one, sir?
Fire resistant one, sir.
Okay, sir. Good, sir. Thank you.
It is already approved, sir. So most of the, you can see in India now, but before like 2013 or 2010, in China or other countries, they have printed offices, they have printed bridges, that already now running, sir.
Okay, sir. Yes, sir. Yes, sir. It is okay, sir. Thank you.
Hello, sir.
Sir.
One question is came from the chat box. That question was, how does it reduces the weight? I am asking about weight savings. He is asking about weight savings.
Yes, sir. So what we can do, suppose if you have any part without disturbing any applications, so weight savings is whether the I have shown some part. I will show you that PPT. This is for your answer, sir. This part is conventionally part. So you can see this area is fully solid, and whatever the area is, this also very fully solid. So what there is a software called any Simofact or simulation like Alter software is there. Both softwares are for the simulation, thermal analysis, structural analysis, thermomechanical analysis they will do, and also topology optimization. You can see the main application of the area is this here. It is fitting in somewhere. This area fitting is somewhere. Wherever the holes are there, it is fitting in other area. So here software is given. So where the load is applied, we have given. How much pressure is applying, we have given in the software. So accordingly, where the fixing is joints, the joints also we have given the software. Any Simofact software is there, the Alter is there. So what we will do, here we have given all the parameters, working conditions, temperatures. So accordingly, software what they will do, without disturbing any application, here you can see the holes. You can see here holes, wherever the holes is there, 4 holes are there. So here also it is reduced. So this is not required for the conventional process. Here the weight is reduced automatically without changing any application, without changing any temperatures, without changing any pressure, and it will withstand equivalent to this part. So software will give approximately, suppose if you give 10% reduce I want, so it will show whether this part is 10% we can reduce or not. If we reduce also, it will withstand as per the physical application, or it will show. So what we can get the report that if the part comes under the green, we will give the tolerance values plus or minus 0.5 or plus or minus 1 mm. So the software will give within the tolerance, whatever the application is there, this part is withstanding, it has to be withstand. If it is whatever the values we have given, if it is not withstanding also, it will show red light. Sir, this area is bending, so you have to improve this design. So as per that, we have to give the tolerance values, load areas. Accordingly, the software will give the exact STL files.
Okay, sir. Thank you, sir. Thank you for your wonderful explanation. So any other questions from the participants?
Sir, this is, I'm audible, sir.
Yes, sir.
Sir, this is Madan, Dr. Madan, Assistant Professor, Kamraj College of Engineering Technology, Virudhunagar. Actually, my question is on about National Center for Additive Manufacturing. In slide, you are telling that is located at Hyderabad, correct, sir? And what are the things they are doing, sir? Actually, you are during the presentation, you are telling about metal additive. We have the metal additive manufacturing. Any centers available in South Tamil Nadu, and what are the activities you have done, sir?
One second, sir. Actually, sir, this center is established by MIT, so it is mostly developing for additive manufacturing only. So we have to go for the companies who are not adopting additive manufacturing. So we have to uplift the industries in additive manufacturing. We have to guide them that this is the benefit of additive manufacturing. So we will to explain this is a conventional process. You are losing this much of amount, this much of time. So we have to uplift the additive manufacturing, sir. Then second is we are giving faculty development programs, skilling trainings regarding additive manufacturing. So, and also we are giving here trainings for the different type of industries, whether faculty, there are multiple faculties are coming regularly in our facility. We have plastic machines, we have composite machines, we have laser 3D scanners. We are training them to get here last month there are 100 plus students are came. We have given like 15 we have divided into that. We have given the training about designing to direct 3D printed part. So skilling also we are doing for students, faculty, and also industries. Then, sir, other is new technologies. Suppose, sir, if you have very good technology which is not available in India, so you can come to us. We will, our technical team will guide you, and we will check your feasibility. So accordingly, we will fund also, sir.
Sir, another question: are you offering any internship courses for?
We are offering, sir, every 3 months we are offering around 10 plus internships. Now next 1 month we are going for the 10 plus internships, sir. For internship, they will come here, they will learn about how to slice metal part, metal 3D printing, SLS 3D printing, FDM 3D printing, slicing to post-processing, metals post-processing, SLS post-processing, FDM post-processing, and also they will recruit, because wherever the companies are there, they have to report to us, because our EPIC center in India, any private or government sector, they have to report to us. So what we will do, we will connect them. Is there any recruitment? They will contact us. Who are eligible, they are well knowledgeable person, they have done training here, so they will get the placements also in different industries.
Okay, sir. Okay, sir. Thanks for the explanation, sir. And we will touch you after the session.
Sure, sir. I have given my number, sir. If you have any query, means any technical needed, or any, suppose if you are purchasing any machines for your project, whether this is feasible or not also we can explain you, sir. Any brand is good in the market, which printer is good also we can tell. And also any colleges, any students want to visit our facility to get trained, or one day you can visit our facility, you can see our facility, we will explain entirely our end-to-end process, sir. I have given my mobile number. Yes, sir. This is my mobile number. If you have any AM related, application related, R&D related, you can contact me, sir.
Thank you, sir. Thank you, sir.
Okay, sir. Thank you, sir.
Sir.
So, dear participants, any other questions? Yes, any other questions? Okay, sir. No more questions, sir. Dear Praveen, sir, on the behalf of our organization, and sincerely thanks for taking the time and to sharing your knowledge and expertise with us during this session. Your insightful presentation and practical application great enriched the learning experience for all the participants. So we deeply appreciate your effort and contribution, and we look forward to further opportunities for collaboration. And thank you very much, sir.
Thank you, sir. Thank you, sir. We have known each other for last 6 years. So
yeah.
Yes, sir. Thank you so much, sir. Thank you.
Great, sir. Great, sir. Thank you, sir.
Thank you, sir. Can I left, sir?
Okay. Yes, sir. You can leave, sir. Thank you. So, dear participants, the next session will start immediately. So, already the resource person already joined. Yes, sir. Ravi, sir. Are you there?
Yes, I am there. I am there.
Okay, sir. You can share the screen, sir.
Hello. Good evening, everybody. I am audible to everyone?